Hello. Well, I explained to them, this is a workshop local here in Palab León in Spain, but I opened this for online because I want to explain the project, okay? I have all the documentation in this web page. I'm going to show you, and I put the link in the chat. Here, okay. Well, the Adrianino born the last year when I finished my FAB Academy. You can search me with this project. Yesterday I graduate and I won the first person to present the last year during the pandemic mode. And it was awesome. Well, always with Fiore, we remember. And I create this project during the summer. And I think to create this project because a lot of people in academy have problems and issues with the electronics. Yeah, I think sometimes we are afraid to create your own board and soldering and electronics. And I create this board to have this tool in the FAB lab, okay, and give to the students during the FAB Academy, and then can connect different inputs, outputs, and they test it with this little microcontroller. This is the new generation of the microcontroller. It's the ATtiny1614. It's very easy to program. It's more easy than the others with the ATtiny44 and 45 with the FAB ESP. I think it's clever and then remember during the FAB Academy. And now you can program with only 3 pins, okay, with the UPDI, VCC, and ground, okay, with these 3 pins, you can program this little microcontroller. In this case, you have an FTDI to read and send information to the microcontroller. We have a little regulator. You can put the power supply of more than 9 volts, okay? And the voltage inside of the microcontroller is 5 volts, okay? Then I have this little connection, okay, with 5 volts in one part, 4 inputs or outputs, and ground connection, okay? And then we have a little connection for the I2C communication, for example, an LCD or an Oled. Another LED is very easy to debugging with when you start with the microcontroller, a little button, and another three pins with inputs or outputs and ground connection. Okay, it's a very powerful because you can use only 1 pin for program and the other pins, the VCC and the ground, you can use all the pins. Okay. Here in this web page, I put all the data sheet of this microcontroller. You have 14 pins, okay, and you can see here the analog and digital pins. Then I have the boom and the schematic, and you can find all the components here. And here you can find the board design. Here we are sent the Gerbil to China, and we create a little kit. Oh, there's another person. I create a little Gerbil to soldering more easy for the people, and we want to create this little workshop here in Palab León, because I create several Adrianinos. I'm going to stop the sharing. You can see this is the first Adrianino. And when I prototype this first Adrianino, I put the VCC in this pin. Okay, I put the pin, the VCC with the color red, and the color white is the ground pin. Okay. And when I finished this, I talked with Neil Gersenfeld, and he told me, okay, I prefer to change the pins, and I prefer to put the VCC to the other path. And this is the Adrianino version 1. And then I create the Adrianino version 2. The difference is only, you can see the here, the pin, okay? It's only the one version. And I send the Gerbil to the, there is a lot of companies to create the PCBs. And I create this little PCB to very useful to prototype. It's more easy than the other. And for soldering, okay? I continue with this part. Okay, this is for the programmation, okay, with the programmer. In this case, you can use an FTDI. This is the new programmer that Neil creates, is with a FT230XS microchip. But this is more or less is obsolete because Neil improved a lot, and he creates another version of programmer. I need to update the documentation, but with this little chip, this is the SAMD 11. This is the new generation of the SAM AMDs, okay, the SAMDs. And in this part, you have the FTDI, okay? Because in this case, you have, it's similar, okay? Oh, sorry. It's similar. This is the SAMD, and this is the FTDI 230X. Is the microchip of FTDI, okay? And with another cable with FTDI, you can program it because you need only this little converter, okay, with a little resistor in TX and RX in parallel, okay? And with this little resistor, you can upload the UPDI system, okay? You connect this here, and you connect with the little board, the Adrianino, and you, oh, sorry, this is the old version. Here, okay? And you can program it with this, okay? If anyone have questions, you can answer. Well, and this is the operation, okay? I put all the parts in the documentation. This is the part of the programming, okay, with Windows and Arduino. This is the bootloader to upload the program. And you can select well, you can follow the instruction. Is very easy to Megatini Core, okay, with Quentin and Spence Conde works a lot. Yeah, you select the port and upload the program. You can see the progress of the program, and you can see a little video of the programming. is the normal example is the blink, and you can see now the LED blinks in the program. Una. Well, and this is the old version with PUPDI, okay? With the first year, the last year, we start with this protocol to program it, okay? But this now is obsolete, more or less. Well, I put different videos, but one of the more important things to this project is to create a little repository of different inputs and outputs, and you can connect to this board, okay? And here in this web page, you can follow all the inputs and output devices you can connect. Okay, for example, you have the button, okay? You can here see the button, and you have the Arduino code here. And you have a little example of the video with working. Okay. Another sensor is the pyroelectric. You can see a sample with processing to see the movement of this sensor, the pyroelectric. And you can see a lot of examples of input devices with the ultrasonic, with the time of flight sensor. Another version of the time of flight. This is the Hall effect. I talk about the modules, okay? You have this little module, okay? You can connect this little module, you can connect to the pins. And in this part, you have the VCC, this part is the ground, and only you need you need one pin to connect the sensor, okay? And I put the different, the EGL design and the PNGs to download and create your own Hall effect module, because it's very easy. You can use this for connect to the Arduino, for example, if you prefer. Here you have the sample, the temperature sensor. The phototransistor is similar, a little module. Okay, this is a new sensor. Okay, this is a new sensor of color. This is a little module. And with a little regulator, you can see the different and detect the different colors. You have all the code for Arduino here. And then I have a little sample with the different papers, colors. And you can see the graphics movements, more or less, because it's very unprecise sensor. And this is another sensor. You have a little okay. Well, this is the 3-axis accelerometer, and the same you can connect with the I2C. Okay, it's important to have here this little resistor in pull up, okay, to connection the I2C protocol, okay, because if you didn't put this resistor, you have a lot of noise in the communication, okay. We continue with accelerometer is here, okay. Well, you can see the graphics. I create this for I think it's a tool for the student to understand how it works, the different sensors with a little program, because sometimes you don't know to program. Okay, you pick up different examples in the repository and you can upload, and you don't know if it works or not. Okay, and I create for this for the students and for the labs. Another sensor, and Neil likes it a lot, is the step response. And I create 2 different examples with, for example, a paper. You can push and see the variation of the movement. Okay. And if you have a sponge, you can see in between the different electrodes, you can see the different pressure. Okay. And then we jump to the outputs. Okay. We have the LED RGB. It's more easy. And then the NeoPixel ring. You can see you can put the different jumpers, the cables, and connect. And here we have the example. I have used the 9 volts input, okay, the power supply. And it's important to see the libraries, because you have a 16 Ks of memory inside of this little microcontroller. Okay. With the LCD, the I2C, okay. The OLED is similar. You have the program, because you need to, you need to know what is the direction of the I2C connection, okay? And you have this little program to scan this number, okay? And you receive the number in the serial, okay? This is a little example with Hello World, okay? I love the Hello World inside of the OLED. The DC motor with a little Allegro driver, okay. It's important to see the footprint, because sometimes we have problems. You can see the sample. And when I press the button, I stop the motor. Okay. The servo with the cables you can connect. And the stepper motor is the last output upload to the documentation with the 2 Allegros, the drivers. As you can see, the movement with a power supply more than 12 volts, okay. And then I put a little part of communications, because you can connect this Adrianino with a Bluetooth module, okay? Because this part is similar than the FTDI, and you can connect. I put the different steps to programming, and know what is our type of Bluetooth module. This is the connection in the FTDI part, okay? I create a little app inside of an smartphone, and when I connect it, I send numbers, and the different numbers, you can see the LED blinks, okay? And there is the little examples to create to learn a lot. And yeah, I have this part. I need to update this photo because I have more modules to connect to the Adrianino. And yes, I have the Gerber here to download. You can send the Gerber to a company to create your PCB, or I think it's more easy to mill your PCB with the Modela, for example, or a little CNC mill, and you can find all the files here. I don't know if anyone have questions. Or there is a lot of things.
What kit would you recommend starting with to be able to build all that?
Well, I think it's very easy to start with this little microcontroller, okay? Because it's more easy to program, because if you have an FTDI cable in your home, for example, or in your lab, you can program it very easy, okay? It's more easy than the other version with the 80Tiny44 or 80Tiny45, because you need to create your own fab ISP to program it, okay? And now it's more easy, okay? Yeah, you can create your own Adrianino, or you can redesign, and you can, it's important because you can connect the different modules and you can test the different sensors or output devices. You can know how it works, okay? Because for a new student, when he arrives to the Fab Academy, you have 1 week to electronics production, okay? You need to create your own programmer. For example, you can create this, the FTDI, okay? But the next week, you need to create a hello world, okay? A hello world is a little microcontroller with a LED and with a button. And another week, you need to program it, okay? And well, your instructor can help you, okay? But there is another week you need to learn the input devices. And you can think, okay, I want to create the input devices for my final project. And for example, I need to use a phototransistor or an ultrasonic sensor. Okay, with Adrianino, you can have this little module, you can test it. For example, you can test it the phototransistor and the ultrasonic sensor. And you chose, okay, I prefer to select this because I have more precision, for example. Or the same thing in the output devices week, okay? Because in the output devices week, for example, you have in your project, you want to use a servo motor or want to use a DC motor, and you don't know, okay? Here you have the code, here you have the connection and the schematic to program it and the connection, okay? And you can test. I think this is the reason of this project. I don't know if, Jackie, I answer your question.
Yeah, thank you. Yeah.
Okay. And yes, I create this workshop to here in local, in León, we are going to create the students. I'm going to stop the sharing. Different people, the different people come to the lab and they want to create his own Adrianino. Okay, but you have all the documentation in this web page. You can download the files. You can create your own Adrianino, and you can soldering, learn, programming, and learn more.
Did you still have a radio project in the Fab Lab?
This is one of the steps I need to complete because I want to communicate with different IT tinies, okay, with radio, okay. In this case, I have here, going to the web page. In the assignments of networking, here, I create a serial bus with the IT Tiny 412. This is the brother, the little brother of the IT Tiny 1614, okay? And in this case, I send the information to the bus and blink the different LEDs, okay? But yes, I want to create the IT Tiny new generation with the radios. I have the modules, but I didn't start.
Yeah, that's well. We'll just follow you on the website. That you'll document it here when you have it done, right?
Yeah, yeah.
Great.
Thank you, then. Thank you. I don't know if anyone has more questions.
Well, just a comment. I mean, you've done a fabulous job here. You've got the whole Fab Lab electronics.
Oh, thank you.
So well documented. I wish you were around like 10 years ago.
Yeah. Well, the last summer is very, you need to stay home, you can't travel, you can't visit other cities, and okay, I have a lot of time in the weekends, and I start to different electronics documented, but this is amazing, and I'm very awesome to see my work.
Yeah, well, it's a lot cleaner with the FTDI cable, and I like the way that you have, so many different options to interface to the chip.
Because you only need, I'm going to stop there. You need only this little module, okay? You can have an FTDI cable and no problem. You can connect the FTDI cable here, and you can put the UPDI, the VCC on the ground. Because Neil, when he starts with the, I'm going to share this. For example, in the week of the Hello World, here, the electronics design, okay. And in this case, I'm going to here. Come on. Okay, here you have only ground, okay, and sorry, this is ground and this is UPDI, okay. And the VCC, you need an FTDA, okay, and you have 2 FTDAs to program it, and this is the program, and I implement another connection with the VCC because it's more easy, because only with one FTDA in your home you can program it and you can read the data with the FTDI, okay. In this case, you need, here you can see, you need this FTDI to power the board, okay? And here with this, you can program it. And this is the program. I'm going to, yes, here you can see better. this is a normal FTDI, and you can connect this FTDI to with this converter. Okay. But yes, this is the little project of the Adrianino. I don't know if anyone has more questions. I see Rusian and Podja. Hello. You're welcome. I have a question in the chat. Hello, Rusian. Well, question. No question. Okay. Well, now here we can start the local workshop. I'm connected, and if you have a little CNC or modeler, you can create your own Adrianino. And if you have questions or something similar, you can write me in the GitLab, in Mattermost, in Instagram, Facebook, what you prefer, or send me an email. My email is this. I put in the chat. And I can answer your questions or your issues. Now the electronics is more easy. I love it, the electronics. Well, if anyone don't have questions, I turn the computer and start with the workshop with the soldering here with the people. Thank you, then, and good night for you. You're on mute.
Or good morning.
Yeah,
Yes.
yeah. Thank you.
Okay, well, enjoy your workshop. Thank you so much for leading this workshop.
Thank you so much. It's amazing. Okay, I want to start with the workshop here. Hey, oh, no problem. And Rusian and Gleb, Podja, if you have questions, you can talk. We can hear you. I'm going to switch to Spanish and English between, but no problems. Hello, Elia. No. Helia, I explained the project here in the first half an hour, or sorry, the 30 minutes, because this is a workshop local and online, and I explained the project. I put the link in the chat because I explained the first part about this project. If you have question, I can answer you. And I start now with the local workshop here, because you need to have this little word, okay? You can see all the files inside of this web page. I don't know if I'm here, okay? I'm going to start the workshop and you can talk, okay? Oh, I'm going to switch on. Oh, sorry, Delia. Well, you can create your own board, okay, Delia? Because here we create the little board. We send the board to China, and we create the board for the workshop, okay? But if you have a little model or little CNC milling machine, you can mill your own board when you prefer. Yeah.
Hi, Adrian, how are you?
Hey, Lucy, I'm fine. Congratulations.
Thank you. I think we will meet on the ceremony later. Just a second, I switch the camera.
Because today you are on graduation?
Yeah.
Okay, awesome. We see it.
Yeah, nice. Yeah, I don't know, like after the graduate, I don't know if it's a good place to have this kind of small talk.
No, we open the last 10 minutes and say hello, and this is all.
Okay, yeah, no problem. Like, I don't want to interrupt you, but I just want to, I saw your name, I want to come and say hello. And
Yeah, no problem. You're welcome. If you have issues or something to learn about Adrianino, you can ask me, no problem.
I think at the moment it's no problem because I remember I saw your documentation. It was really clear. All the procedure, pace, I can follow really well. Like also for the sensor, it's kind of part of that. So yeah, it's quite clear for me.
Okay, thank you so much, Lucia.
Okay.
You're welcome.
Yeah. Then maybe see you later on the ceremony.
Yes, of course.
Okay. Yeah. Ciao.
Ciao. Yes, Gleb. Thank you. The last week, Ivan Miliara came to León and visited us, and I give you to him a little Adrianino, and I think he can show the little board. Well, I'm going to switch on the other camera with the micro. Yeah, it's amazing. I'm going to visit it all soon as possible with the pandemic. Okay. Yeah, I think it's better. Okay. Well, hello, Selena. You're welcome. Yeah, Russia. Yeah. I need to visit the north of Europe. I hope soon.
Or I can visit you at León.
Yeah.
I mean, I was in Germany and that was closer.
Yeah. Now you are in Germany?
Not at the moment. I come to Alto for like exchange student.
Okay.
It's until like the end of this year, Christmas.
Okay.
So I will back to Germany, and where is like Weimar. I don't know if you know the small city. And
is near to?
not that near, but from there to visit Leon is like really.
Yeah, but in Germany, what city is?
Weimar.
Weimar is near to Frankfurt? No.
Near.
Weimar. Okay.
Yeah. Like the middle part.
Yeah.
Yeah. And like last Christmas, I visit Leon as well, but I didn't know.
Yeah. 2 years ago, I visited Nuremberg and Munich, Dresden, Leipzig.
Yeah, that's really close.
Yeah.
But at the moment, I'm in my summer vacation. I'm in Taiwan now.
Okay.
Yeah. Oh, I interrupted again.
No problem.
Yeah, I thought maybe you have like the thing to tell, to share. So
yeah, I'm going to start here with the little minions to soldering. Okay, thank you guys. I think, I'm going to change the camera. Okay, you can start with, select your position. Yeah. This is for you. This is for you. No. Okay. You can select your solder. We have select different power supply. Bueno, podemos cambiar al español. Sí, pero bueno, no hay problema. Es que está en alto. O sea, estudió en alto y está de ¿cómo se llama? De intercambio. No sé exactamente. Sí. ¿Tú fuiste? Sí. Thank you so much. Glad. Have a nice day. Bueno. First of all, we need to search the little microcontroller, okay? This is the... No, es que esa no me funciona. Es un poco random este workshop. You can see the little microcontroller, the IT Tiny 1614, okay? And you see the little dot here to put the camera bigger. Here. Okay. Okay, you can see here the little dump, the little dot here. Oh my goodness. A ver, enfócate, por Dios. A ver ahora. Well, you can see the little dot here, and there is another little dot in the board. Okay. Yes. This is the position of the microcontroller. Okay. First of all, we need to solder the microcontroller because it's the little component and the very important component of this board. Okay. The smallest. The smallest. Yeah. And remember, you need to put a little. What is this? Wow. In this case, it's very easy to solder with these little boards because it's pre-soldered, okay? And when you put the hot, there is no problem. Yeah. This is. Y esto se va a ver en YouTube, amigos. A ver en YouTube. Well, you can pick up some Okay, first of all, you need to solder the microcontroller, okay? And remember the position of the little dot. Okay. ¿Qué te falta? ¿Soldador? Podéis compartir soldador si queréis. Como veáis. Ese igual es muy gordito. Computer type. Bueno, ese no es muy bueno. Son todos, a ver. This board is easy to solder because it's pre-soldered and you don't have near the traces, okay? If you have a little issue, you can retire the solder. It's pre-soldered, the PCB, okay? ¿Qué haces, animal? Vale, hombre. You see, Gustavo, you can see here a little dot, okay? And here you see the little dot of the microcontroller, okay? It's very easy. You need to read the... Amazing. Alguien se está quemando. Sí, hay estaño allí. Pasa, un trocito de estaño para... Me vais a fundir la placa. ¿Qué te pasa?
Toma, limpiada.
A ver, podéis compartir si no el soldador luego, el vecino. O sea, no tenéis por qué hacer todo. Qué exquisito.
¿Qué estás haciendo? Es otra cosa. Ah, vale.
A ver, ha llegado el pijo del huerto. Toma, Flux. Pero, Sergio, ponte a soldar el microcontrolador. Sí, sí. Voy a mutar aquí, Mauro. Remember, Sergio, you can see here this little dot, okay? This little dot and this little dot. You need to put here, okay? Then when you are soldering the 8090, you can solder the pull-up resistor for the I2C communication, okay? Remember, I think you are the 472, I think. Right. ¿Qué fijo sois? Hay flux, sí. Hay. Mauro, ¿me pasas el flux? No.
Aunque tú no vas a usar la misma expedición.
No, my repository changes because the thing is send me different resistors. Okay, you need to solder the I2C resistor pull-up. Okay, it's important to the communication because with this little resistor, you don't have noise in the communication. Okay. Then we have a little 1K resistor for the LED. This is the other component you can solder it. Then you can solder the bottom here. And we have a pull down resistor of 470 ohms. Okay.
Could you please explain what is a pull down resistor?
Yes. The pull down resistor, you put the pull down resistor because you put the pin in the state of open the button to ground, okay? And you don't have noise inside of this pin, okay?
Noise in the signal.
Yeah. Then we have the little capacitor of 1 microfarad, okay? Is here. It's amazing with the microscope. And finally, we have the regulator to regulate all the board with the power supply. You have, for example, 12 volts or 9 volts. And have the power supply of 5 volts to the microcontroller. And then we have the different pins. We have the pins. I put the colors for the different VCC, ground. In this case, we have the power supply. Okay, it's similar than this. This little thing, you can have the same power supply. In this case, you have, for example, for the motors or the step motors, you can power supply the step motors. Then we have 8 volts connection. And here we have 4 inputs or output devices. And then we have the ground connection. Here's the connector of the I2C, okay?
Wait, I'm not following.
No problem. I'm talking because I'm recording. Okay. And then we have this connector to the input or output devices. Okay, we have 3 pins, and then we have 3 pins of ground because you can connect to the ground and the signal of your microcontroller. And this is the 3 pins for the programming, okay, with the UPDI. And finally, we have the FTDA connection with the 6 pins with RX, TX, ground, and VCC. Okay. I change the camera. This is the board. If you have questions, you can send me an email to Adrian Trains gmail.com. Okay. Thank you so much and enjoy the FAT16. Bye bye.